In the second example in lesson 5.2, we're going to be rationalizing the denominator, which basically means we're going to be learning a process that can be applied to remove a radical from the bottom of a fraction to the top of a fraction. So first of all, we need to understand that if we are simplifying radicals, there are some rules. You can never have a fraction appear with a radical sign over it. If you have that, it must be simplified further. Second, you can never have a radical that appears in the denominator, which I already mentioned. And then third, given example 1 that we've already looked over, you can never have a number under a radical that can be simplified, like we did in example 1. So here we have in example 2, the radical square root of 2/3. Clearly, we violated that first rule. 2/3 is a fraction that sits underneath the radical, so it is not simplified. What we need to do is think of this as the same as being the square root of 2 over the square root of 3. In this form, we have violated the second principle or rule that I mentioned, and that is that we have a radical in the denominator. So what we do is we simplify or move that radical from bottom to top by rationalizing it. So we rationalize by just multiplying the top and the bottom of this fraction by the same radical. Therefore, we're just multiplying by 1. And the radical that we multiply by is what we see in the denominator. So we have square root 3 in the denominator, so we're going to multiply top and bottom of our fraction by square root 3. By doing so, we're going to get square root 9 in the denominator. And we know that the principal root of the square root of 9 is 3. Therefore, the radical has disappeared from the denominator. In the top, we just multiply square root 2 by square root 3, and we get square root 6. So just like multiplying 2 by 3 gets 6, multiplying square root 2 by square root 3 gives us square root 6. Now, if 6 could be simplified, we would be expected to do so. But there is no perfect square that divides evenly into 6, and therefore, square root 6 over 3 is our simplified answer. So in example 3, we start with the very same scenario. We have the square root of a fraction, which is the same as the square root of the numerator over the square root of the denominator. Pause a moment and think about what we may need to multiply the top and the bottom of this fraction by to eliminate the radical in the denominator. And that would, of course, be the square root of what we have on the bottom. On top, we'll get square root 35, like we did in example 2 above. On bottom, we'll have square root of 49, which, of course, has a principal root of 7. The square root of 35 cannot be simplified any further, and therefore, our final simplified answer is square root 35 over 7. In example 4, we start with a square root of a fraction again, which once again means it's square root of 9 over square root of 8. But in this example, what we can do to make our life a little bit easier is we can recognize first that the square root of 9 is 3. The principal root of the square root of 9 is 3, which is the one we're expected to use here. But the square root of 8 can be simplified. If we think about our list of perfect squares, the largest perfect square that divides evenly into 8 is 4. So this is the same as the square root of 4 times the square root of 2. And we, of course, know that the square root of 4, the principal root of it, is 2. So the square root of 8 simplifies to 2 root 2. If we simplify that radical in the denominator first, it's going to make this process a little bit more efficient. Now all we need to do is multiply the top and bottom by that square root that's in the bottom, not by the number in front. We only care about eliminating the square root. So we multiply the top and bottom by square root of 2. On top, we'll have 3 root 2. On bottom, we know root 2 times root 2 is root 4, and the principal root 4 is 2. So on bottom, we'll have 2 times the 2 out in front, which means on bottom, we'll have 4. Now, if the 3 over 4 could be reduced or simplified, we would be expected to do so, but it cannot be. And therefore, our final simplified answer is 3 root 2 over 4.